All right, folks, let's have some fun and let's solve some radical equations. These guys are actually totally radical equations. Anyways, we're going to start off with one example. Well, let's call it example 1, right? And we'll divide both sides by 2 of the equation. Divide by 2, divide by 2. We then end up with just square root of x plus 1 equals 2. And I'm kind of curious if you could just guess what the next step is. While you're guessing, I'll go ahead and get my, I'll change some ink here. Hopefully you guessed that we're going to square both sides. I'm going to go ahead and raise this left-hand side to the power of 2, and I'll raise the right-hand side to the power of 2. And when I do, I should get a pretty cool result. This side is just x plus 1, so that's really neat, and then 4. And then that gets me, we need more color, don't we? That finally gets me something like x equals 3. And we could box that answer. Now, it turns out when we're solving radical equations, there are values of x which are not valid. In other words, they're not in the domain of this radical. Anything that, you might recall that if I try to take a square root of a negative number, I get something that's complex or imaginary. So the problem is that if there's a value of x that makes the whole radicand, everything under the radical sign, if that value falls below 0, then the value of x is no good. In this case, 3 plus 1 is 4, so that's fine. This is a good solution, x equals 3. You might recall from when we looked at rational equations or functions that if we get a value, if we solve and get a value that is no good, we call it extraneous, and the same is true here. Let's take a look at another example. Okay, let's see what we can do with a radical equation that has a root other than 2, in this case a cube root. We'll go ahead and we'll add 1 to both sides. Just like we did with absolute value equations, we're going to get the radical by itself first, and then we'll worry about getting the variable by itself. So we just add 1 to both sides, and when we do, we get the cube root of 2x minus 9, and that is equal to 3. Now, I kind of like you guys to take a little bit of a guess and see what could I do to make it so that this cube root goes away. Pause the video for a moment and see if you can guess what it might be. Okay, I hope that you are back, and I hope that you thought that maybe we could go ahead and raise this guy to the power of 3. And you're correct if you did think that, and we'll do that to both sides. And then we get this really neat result that on the left side we just get 2x minus 9. I love that. I hope you do too. Anyways, on the right side we get whatever we get. It turns out in this case 27. And from there on out it's pretty simple. So I'm just going to kind of move through. Add 9 to both sides. That looks like 36, I think. Divide both sides by 2. That gets us how about x equals 18? And then the only other thing is we got to double check and make sure is the result extraneous. Now, the good news is this. Because it's a cube root, x can be any value. It can be positive or negative. Unlike over here, let's see here, when we had a square root, square roots, the radicand must be 0 or positive. For cube roots, the radicand could be a negative number, and that would be fine. You can take a cube root of a negative number, you get a negative result. Okay, let's get through a few more of these. I'm having fun. I hope you are too.